Okay, today we're going to be talking about dilations. We kind of went over this in December. If you open up your notebooks to page 36, you're going to see some of the same exact problems we're doing right now. So, what is a dilation? Anybody? An enlargement or a... Alright. Or what? No, an enlargement or a reduction, shrink. And today all of our dilations will be proportional. Dilations produce what kind of figures? Similar. What does that mean? Same shape, not the same size. And remember, just as a reminder, the similar symbol is a tilde. What I need you to remember is that angles will remain the same. Just because the size of the shape changes, the angles will not change. Okay? So, does anybody remember how to find scale factor? What? You're going to end up using scale factor and multiplying, but how do you find it? Divide what? The image by the free image, or the new divided by the old. Which one is my image here, or which one is new? Yeah. And then this one is old. The one with the primes is the new, the old, and it gives me 5 and 10. So what is 5 divided by 10? 1/2. Does that make sense? Did this shrink? Yes. So before you answer a question and move on, make sure it actually makes sense. If you got 2 and it gets smaller, does that make sense? No. What is the diameter of the image if the scale factor is 3/2? If I give you the scale factor, how do you use it? You could turn it into a decimal, but what are we going to do with it? Multiply. If I know this is 8 and it has a scale factor of 3/2, I am going to multiply it by 3/2 to get my new diameter. Does anybody know what 8 times 3/2 is? 12. And it didn't give us any units, so we're good. Last but not least, what about these hexagons? How can I find the scale factor of these hexagons? New over old, which is what? 104 divided by 8. Does anybody know what that is? 13. So my scale factor is 13. Do you agree all of that was review? Aiden, you have that written down? Write it down. Pick your heads up off your desk, please. And write it down. All right, open up your notes. Now everything we're going to be doing is graphing. Oh, actually close your notes real quick. Thank you. The dilation rule that we are going to be dealing with is going to be xy, and it's going to end up being the scale factor times x, the scale factor times y. That is your dilation rule. You write that down. Yep. Yes. XY, arrow, boys behave, becomes the scale factor times x, the scale factor times y. Yes.
Since x is going to be a number with the answer we have it multiplied.
So if it's the rule, you're going to leave x as the letter x, just like we have been in our rules. But whenever we're finding things, it'll be number, yeah. All right, can I change this? Did you write that down? Wonderful. So number 1 says WXYZ across from DMC. It's where that window is. Like right over here. Yep.
Okay.
Yep. All right. WXYZ is dilated about the origin. Complete the rule. How is this dilated? What is the scale factor here? How do we find the scale factor? Just count. I'm going to count the top. How many units is that top one? 1. Look at my board, please. How many units is this one? 4. And if we do new over old, we do 4 over 1, which is 4. The scale factor is 4. Do y'all agree with that? So what's my rule going to be? XY transforms to 4 times X, 4 times Y. And that is the rule. Boys in the back, look up here, write it down. Any other questions? All right, I want you to attempt example 2 on your own. Go. Look at the primes. No. I know it does, but no, you're looking at the 2 different triangles. Everybody in here is doing example 2. Go. Kevin, you already do it? Example 2. Did you get 3 for BC? Did you get 9 for B prime C prime? So what's the scale factor? 3. If I know the scale factor is 3, and I know A prime C prime is 10.8, how do I find AC? What is 10.8 divided by 3? 3.6. Angle BAC. If angle BAC is 50, where is angle BAC? But where is angle BAC? But where do I put 50? No. If you start at B, go to A, then go to C, BAC. Remember, it's always that middle letter, A. So that is 50 degrees. Does that make sense? If that's 50 degrees, what is angle B prime, A prime, C prime? Remember, your angles are the same. It is also 50 degrees. Don't multiply it by 3. It's not a side. These triangles are, so which symbol do I use? The tilde. They're similar. If you don't remember that, maybe write it down, similar. Was any of this new? No. All right, if your head's on your desk, pick it up, write this down, please. We have D, E, F, G, and if you dilate it about the origin using this rule, determine if the following statements are true or false. Well, let's dilate it. How do I dilate it? I don't know. Let's get the, I could count the sides, but that's not going to help me on where it goes. So I'm going to get every point. Yes. Get every point and then multiply it by 1/3. So what point is D at? -6, 7. Wow.
Come on.
I didn't make this. I wouldn't do that. All right. And if I multiply both those numbers by 1, I know, it's killing me too. By 1/3, what am I going to get for my D prime? We're just going to be really mature about it and move on. What is -6 times 1/3? -2. Yeah, use your calculator. What'd you ask?
It's about the origins. So which the 3, 3, 3?
No, because you have to look at where this is at. Yeah. And then what is 7 times 1/3? 2 point what? Okay, we'll just do 2.3. And then plot that. -2, 2.3, somewhere right there. Estimating is what I like to call it. E, where is E at? -6, -2. If I multiply both of those by 1/3, -6 times 1/3 is -2. What is -2 times 1/3? 2/3 or -0.6. Well, it technically it rounds to 7. Goodness gracious. It's just playing with us at this point, isn't it? Yeah. That's E prime. F is at what point? 4, -2. No, sorry, it's at 3. Yeah, the letter F is at 4, but the point is at 3. Yeah. Multiply it by 1/3, and what do you get? 1 -0.7. And now that we have 3 of them, can I make the rectangle? Yeah. Now we're going to answer true, false. Is D, E, F, G congruent to D prime, E prime, F prime, G prime? Are they the same shape? Are they the same size? No. Heads up, off your desk, write it down. Is D angle DEF congruent to angle D prime, E prime, F prime? Why, yes, this time. Because we're talking about the angles, not the shape, but the angles are the same. Are these quadrilaterals similar? Yes. I multiplied both x and y by 1/3. They're similar. Is the coordinate of E prime -2, -1? No. It's, I mean, if you rounded it, yeah, but no, it's not. All right. Would you have been able to get that last one right if you had not multiplied these by 1/3? So just be careful. Okay? All right. Next thing we are going to do, can I change this?
Yes.
Next thing we are going to do is we are going to start dilating not about the origin. So, whenever we are dilating not about the origin, we are going to be using slope. What is slope?
Y equals MX plus B.
That's the whole formula, but slope is your M. But we are going to be using rise over run. So it says enlarge JKL by a scale factor of 2, centered at 4, 3. Can I have everybody look up at me, put your pencils down. Look up, pencils down. I already actually gave you this 0.43. Look up. You are going to need to find the slope from this point to J. So look at your papers. How do you get from this point to J? I'm going to go down 4, and then you said what? Left 1. If I want to multiply this by a scale factor of 2, I'm going to double that. What is that doubled? Down 8, left 2. So from this point, now I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8, left 2. This is my new J. Write that down now. Do your slope. I went down 4, left 2. No, left 1. Now I got to double it. Down 8, left 2. What point is that at? 2, -5. Can we now do that with K? What is the slope from this point to K? Remember to always go rise over run. Down how many?
Down 1, left 6.
Down 1, left 6. So a scale factor of 2, what am I going to do? So from here, go down to left. And where do I end up at? -8, 1. All right, you do L. Go. Did y'all go down 4, left 4? So now I'm going to go down 8, left 8. And connect your points to make your new triangle, please. You should have primes. Label them. Y'all have been not very good at labeling. Label them with your letters and primes. We shouldn't have the laptop open. You're just taking these notes. What point is L prime at? -4, -5? What questions can I answer? What does a rule start out with? XY. Now this is still a dilation. So what was my scale factor? So I'm still going to do 2x. But since I did not dilate about the origin, I'm going to have to add or subtract something, because what is 3 times 2? Is that number right there 6?
No.
No. How do I get to 2 if I'm at 6? No. What's 3 times 2? How do I get to 2? Minus. No, dividing. Adding or subtracting. Yeah. Okay, let's check and make sure that works. What is -2 times 2? minus 4 is, does that work? And then what is 0 times 2? Minus 4. So that works for all my x's. It has to work for all of them. Now, the y's, I still did a scale factor of 2, so it's going to be 2y. But I got to check it. What is 2 times negative 1? How do I get to negative 5? Let me do that again. What is 2 times 2? How do I get to 1? And then what's negative 1 times 2? How do I get to negative 5? This is my rule. You don't like the rule part. The rule part's not very fun. What I need you to know is whatever your scale factor is, that's always going to be in front of the x and the y. And then from there, you just have to like figure out what to add or subtract. Yes. Or are you just stretching?
Isn't k negative 4, and then minus 3 is negative 7?
Negative 4. Right here, that's your x.
Yeah.
So on the x's, we minus 4.
So you don't multiply with them?
Now look right here. X's is negative 2. Negative 2 times 2, negative 4. Minus 4 is negative 8. Then for the y's, you do 2 times 2 is 4. Minus 3 is 1. Does that make sense? Yeah. I think you were doing the x with the y. Okay. Let's do this again to make sure we really got it. This time we're going to do a reduction, a scale factor of 1/2. So, if it is centered at 4, 3, let's plot 4, 3 again. And I am a little bit blind, so this is really hard for me to see. What is the slope from from this point to R? I got 12. Did y'all get down 12 or 13? I got 12. So down 12, left 1 is what I got. Down 12, left 1. So if I want to go half, what am I going to do? Instead of multiplying it by 2, what am I going to do now? Down 6, left 0.5. So go down 1, 2, 3, 4, 5, 6. It is going to be a decimal. What point is that R at? It's going to be at 3.5, comma, negative 3. Yeah, that's a little bit ugly, but that's okay. You do S and T. Go. They won't be ugly. They'll be a lot prettier. Mm-hmm. Say that again. Yeah. Yeah, that's a good idea. Thank you. Here's the origin. That help? Okay. It's just 0. Oh no, it's up 6. Did y'all go left 10 for that S? So then halfway would be left 5. S doesn't go up or down at all. What point is that S prime at now? 3. T, I got up 6, right 2? And so what is up 6? I mean half of that. Up 3, right 1, which lands me at 5, 6?
Yeah.
Okay. What questions can I answer? Any questions? Alex, you with me? Okay, cool. What does a rule start off with? XY with an arrow. And then, y'all, I'm actually going to start bottom on this one. I don't want to start with the decimal. That's just kind of annoying. So are you okay with me starting on the bottom here? Okay, cool. So what am I doing here? So I'm going to do 1/2 x and 1/2 y. But we're obviously, because we're not about the origin, I'm going to have to add or subtract something. So, what is half of 6? 3. How do I get to 5? Plus 2. Let's double check and make sure that works. What's half of negative 6? If I plus 2, am I at negative 1? Half of 3? 1.5 plus 2 gives me, so we're good. Now the y's, and unfortunately all these y's are negative. I mean not negative, odd. So what is not half of 9? 4.5. How do I get to 6? And I'm going to do a fraction. What is 1.5 as a fraction? 3/2.
1.5.
Half of 3 is 1.5. How do I get to 3? Plus 1.5, which is 3/2. So it works. This is our rule. Alright. You don't like this? The rule, so I will tell you, I will let you know, you are not going to be tested on finding a rule like this. Okay? It will be on your worksheets. It will not be on your test. I need to finish these notes. Okay. Last thing. Hold on. Stay with me, please. Last thing. Stay with me. Head up. This is review. You've already learned this. But I want to find the center of dilation, and I want to find the scale factor. Actually, y'all can cross out the rules on these. We're not going to do that. We don't have time. Alright, how can I find the scale factor? Just by looking at it and doing what? Counting. We have to do new over old. So our new one is the one with the prime. I'm going to count 1, 2, 3. Oh, you could do that too. I'm doing the bottom. I got 15.
15?
Yeah, if you at the top, you're doing the top, you get 1, 2, 3, 4, 5. That's fine. Now I'm counting the old. What is 15 over 9? Reduce it. 5/3 is my scale factor. 1.6 is, I like scale factors to be fractions. Yep. How do we find the center of dilation? We did this in December. Does anybody remember? How do you find the center of dilation? Can't just do that by looking at it. Everybody get your badge. We got to draw the lines and connect your vertices. Do y'all remember doing that? Connect this vertice to this vertice. Oh, that was a little off. Connect, that was off. My bad. Connect your vertices. There you go. And where do they all intersect? Which is what point right here? 0, 4. I want you to do this next problem on your own. Example 7, go. You do example 7, go. Shh, write it down. Do example 7. Where did they all intersect for y'all?
3,
I don't know.
3 and negative 6.
Yeah, 3 negative 6.
I got -5.
Yeah.
We'll miss
It's like somewhere in between. You are connecting the corresponding vertices, draw a line, and where they all intersect is your answer.
I got a -5.
You got -5? Me too. Okay. Your homework. For your homework, I'm going to assign the evens, 2, 4, 6, 8. I'll bring that to you right now. And can y'all look up? We did not glue in yesterday's because we did not have time. So please glue in both yesterday's and today's. Here are the table of contents.